Okay, I'm going to do an example problem of serial to parallel conversion. We've got an input data stream has an input data rate of 48 megabits per second, and it is turned into 40, 1, 2, n equals 40 output streams, each with a bit rate R out. And we have a very simple relationship here. R in is equal to n times R out. Okay? In the absence of any other information being given about the multiplexing or demultiplexing here. Basically, we can solve for R out as R in over n, which is 48 megabits per second over 40. This is 1 1/5, or 1.2 megabits per second for each of the output data streams. And 40 times 1.2 then is the 48 megabits per second. Okay, so the same amount of data that goes in 1 second also comes out in 1 second. The bit period of the input serial line, T bit, the input line is 1 over the input line bit rate, 1 over 48 megabits per second. And let's see here, 1/48 is about 0.4. Let's calculate it. .021 0.0208 times 10 to the minus 6th, which I could say is 20.8 times 10 to the minus 9th, or 20.8 nanoseconds, let's say. Okay. The bit period of one of the parallel streams we can calculate also, and TB out is 1 over R out, and I don't think I need a calculator for this one, 1.2 megabits per second, and I have 5/6 or 0.833, and then a mega in the denominator becomes times 10 to the minus 6 in the numerator, and I get, let's call this 833 nanoseconds. Okay, and clearly the ratio of the bit periods is the same as the ratio of the data rates. If I want to calculate that ratio, what do you expect the ratio of these two bit periods to be? We expect it to be 40. Let's make the calculation to verify your answer. I'm going to take TB out over TB in, and just go ahead and calculate 833 divided by 20.8, and I expect to get 40. Do I get 40? Yeah, because 4 times 20 is 800. 4 times 0.8 gives me the 32. 4 times 8 is 32. So I think this is going to work. Let's see, 40 times 20.8. 20.8 times 40 is, the 8 times 4 is 32. 3, 8, 32. Yeah, so this is 40. And if I verify it on the calculator, I go equals 833 divided by 20.8. And I do get 40. I get 40.05, but I've rounded off, and so it does check out. And the algebra that goes into this is that if we have Rn is equal to n times R out, then we can write 1 over T B in is equal to n times 1 over T B out. I've just substitute 1 over T for each of the R's up above, and if I cross multiply, I get T B out is equal to n times T B in. Okay, and so it works out exactly how you would expect. Okay, hope that helps on this one. Pretty straightforward, I think.